So welcome back to another video on the solutions of the recently released IIT Kanpur chemistry JEE Advanced sample paper. And today we are again taking up two or three very interesting questions from the sample paper. The first question that we are taking up is a very unique question, and you would have rarely seen this type of a question while solving questions from the chapter of solutions, liquid solutions. And this is based on the elevation of boiling point, and uh, but it has a twist because it involves the calculations related to entropy and therefore enthalpy. So pause the video, give it a try, and we'll proceed with the solution.
So to proceed with the solution of question number 9, the data that we have been given is the weight of the non-electrolytic solute B is 2 gram. The weight of the solvent used A is 100 gram. The entropy, the standard entropy of vaporization at 353 Kelvin has been given as 85 joule per Kelvin mole, and the initial boiling point of the pure solvent is 353 Kelvin, whereas the boiling point of the solution is 354 Kelvin. Now we have been using this formula of elevation and boiling point commonly in many questions, and a point of difference in this question is that the value of Kb has not been given. So proceeding with the calculation of Kb, we know that the formula of Kb is given as RTB square by 1000 LF, or LV rather, the latent heat of vaporization. And LV in turn is equal to RTB square into the molar mass by 1000 into delta H of vaporization. Now how do you find this delta H of vaporization? This can be found by delta H of vaporization is equal to delta S vaporization multiplied by the boiling point of the pure solvent, which is equal to 85 into 353. That turns out to be around 30.005 kilojoule per mole. So this is the value of delta H, and if we place the value of delta H in this equation, we get 8.314 multiplied by the TB is equal to the original boiling point of the solvent, so it is 353 squared multiplied by the molar mass of the solvent, which has been given as 80 gram per mole. So we place 80 divided by 1000 multiplied by 30.005 into 10 cube. Now after calculating this is a hectic task in itself, but give it some time, calculate it properly, and we get to the value 2.757, and this is Kelvin per kg. So we got the value of Kb, and now to proceed with the solution of the molar mass of the solute B, we get the elevation in boiling point 1 Kelvin is equal to 2.757 multiplied by 2 by the molar mass required and divided by 100 into 1000. Calculate this and we get to the answer 55.15. So this is the molar mass of B, and this is the required solution.
Next question that we are taking up is question number 10 from the same sample paper. And the question says, an aqueous solution containing copper 2 ions is treated with excess of potassium iodide to obtain a dark solution P and a white precipitate Q. Now, recognizing from the statement and the data given, the dark solution here is iodine solution, and the precipitate in this case is nothing other than Cu2I2. We know that CuI2 is initially formed, which is unstable, and therefore it breaks down into Cu2I2, reducing copper to clustering state. Now, the solution P, that is iodine, it turns colorless on titration with standard sodium thiosulfate solution, commonly known as hyposolution, and this is again a very common reaction of iodometric titration. And in this process, what will be the number of millimoles of copper ions estimated for each millimole of sodium thiosulfate consumed? So going step by step, the first reaction that we are taking up is copper 2 plus ions reacting with Ki or I minus. So if we see this reaction, we see that the two copper ions react to give 1 mole of I2, producing Cu2I2 as well. And this I2 is further used for the second reaction with hyposolution, where 1 mole of iodine reacts with 2 moles of hypo. So for every 2 moles of hyposolution, 2 moles of Cu2 plus had been used. Or, in other terms, for every millimole of copper ions, or rather for every millimoles of sodium thiosulfate consumed, 1 millimole of copper 2 plus ions was used in the first. So the answer to this would be 1. For today's last question, we are taking up question number 6. Now, this is a type of question that has come up multiple times earlier in the JEE Advanced examination, and this type of question um, involves analyzing the options as a major step. So I've given you the hint. The formula of starting substrate is given, and analyzing the options, we have to guess, or rather we have to identify which are the correct options. So pause the video, give it a try. This is a good question, and this is the type of question that you can surely expect in your JEE Advanced examination. Give it a try, and we'll proceed with the solution. Proceed with the solution. Let us go option by option and check which of the option sets or the compound sets, reagent sets are correct. So beginning with the first option, it is given that this is compound P. Now mind you, the compound P is prepared by the reaction of the starting substrate with HBr in presence of benzoyl peroxide. So this is the popularly known Karash effect, where anti-Markovnikov of addition takes place. So for Br to be added at this position, the alkene needs to be in this position, or rather the one that I have drawn here. So the alkene would be between C and D. I have marked these four positions as A, B, C, and D respectively because these are the four positions that we are dealing with. So for Br to be added here while reacting with HBr in peroxide medium, the double bond will be between C and D. So let us assume that this is the starting material according to the structure of P. Now it says Q is B2H6 and NaOH H2O2 in water medium. So it is nothing but hydroboration oxidation reaction. And if Q is that, then R would be OH at position D. And further proceeding with the next step, it is oxidized to a ketone at position D. And in the next step, MEMGBr reacts with the ketone. It hydrolyzes to give an alcohol, and it dehydrates. So the alkene would come here with a methyl group at the position D that we had marked. So this option is absolutely correct. So option A is correct. Now, to proceed with option B, the Br is added at position B as marked in this compound. Now, for it to be added at position B, the alkene needs to be like this. So anti-Markovnikov addition takes place at position B. The next reagent given accordingly is Q, which is water in acidic medium, and therefore hydrolysis takes place, and OH is added at C position, which is a normal Markovnikov addition. So if the OH is at C position and R is that compound, on oxidation with CrO3 we do not get anything, and hence this pathway is incorrect. Now for the third option, the Br is again at D position, so it is again the same case as the initial one. And if we go back to what we had gotten, S in this case was definitely this. This is correct. Sorry, uh, S in this case was a ketone here, not on that carbon. So this option is already incorrect. So this one has been eliminated as well. Now to proceed with option D, it gives Br at A position. So for the Br to be added at A position, the alkene needs to be present here. So taking this as the starting material and reacting it with AgOSC in water followed by NaBH4, which is nothing but oxymercuration demercuration reaction, OMDM popularly known as. And when we react it with that, the OH is added at B position, normal Markovnikov of addition without rearrangement. And if the OH is at here, R would be OH at this position. On oxidation, it gives ketone. This ketone is formed as S in this option, and this option followed by this S followed by reaction with MEMGBr and a dehydration definitely gives this. So option D is correct. So the answer to this question would be A and D.